have the 5G, but I switched to the Huntington Center Wi-Fi. So I just deleted the first part of my ramble. So I said it's a really good conference, a lot of information here, very important for Detroit, automation, big conference, international conference that moves around locations each year. So it has people from all over the world. And so take advantage of being back. I traversed the whole floor. We made a stream yesterday. People saw that already. I want to check that out. The conference. So I picked up the booklet and read through the booklet. The companies. There's over 500 companies here. It's a conference that includes educational seminars that you have to pay for, kind of expensive. And it has people from all over the world that come and learn from the experts in the direction of the field, plus the convention that I'm attending that has on display robotics, some of the major companies from all over the world demonstrating their technology in a capitalist environment, here to sell. And so the Association for Advancing Automation is a conglomerate of historically many robotics and automation companies that form into one, has many members, including the largest robotics companies in the world, and makes these conferences that brings them all together and includes basically a one-stop shop for everything related to automation, from the computer software, the PLC, materials, backup software. So here they had the chess program. Try to get a little bit of a robotics display. Hopefully I have good enough then. I could also just record this and post it, but if not, maybe I'll just take pictures and grab more reading material. So I wanted to talk about reverse anthropomorphization in the relationship to the hard problem of consciousness. As I mentioned, we know a lot more about how the machine works than how the mind works. And most of the advancements in human consciousness studies are actually reverse anthropomorphizations of how the mind works, mapped from how we know the computer works. And like a simple thing like I'm moving my hand, that presumably there's a volition in my brain or in my soul that there's an I, that there's a desire to do something, and then it's acted out, and then there's neural signals from the central nervous system to the peripheral nervous system, and it results in motion, as opposed to a computer that has code and instruction that consciousness are reverse anthropomorphizations, assuming that the mind works in a similar way to how the computer works. So if you look at a robotic arm, it's not designed in the same way as human anatomy, but it's called a robotic arm. And here you have a very high payload, an automobile that weighs here, I guess over 1,000 kilograms, a Corvette, maybe even more. So Funak, one of the largest makers, a lot of demonstration of their equipment. Some auto companies have hundreds of thousands in Michigan. As I said, Michigan has the third highest amount of engineers in the whole country, even though it only has 10 million people. It's not one of the largest population states. It has the highest amount of automotive engineers, second of industrial engineers. So that's why these conferences come to Michigan regularly, and do what's here to take advantage of that. So I was mentioning yesterday the axis of freedom, the degrees of freedom. We refer to axes. So here's a simple robot, and if you can see, it turns on a 360 rotational at the center, and then there's another circular movement on the arm, and another circular movement. So there's three different axis of rotation here, and four. So this I guess is a four-axis rotation. You can also see that's changing heads in top. So the type gripper, it's replaceable. So it rotates 360 degrees at four, probably five different points here. That so like the arm doesn't have that many axes of rotation, so this would be purposely designed so that the robot could get to any direction from any angle in multiple points of attack, and then the piece at the end is interchangeable, so this robotic arm could be used for different pieces. So for the automobile here, like for the Corvette, an automobile, for an industrial process of manufacture, you could break that down into discrete units, which would be like engineering, mathematics, every point where something is actually done. Either materials being put together, a formation change where it's being changed from one thing to another. So here is a microchip. So you have printed circuit boards of microchips, and you could, if this was a soldering joint, whatever attachment piece that they had, every discrete unit in the manufacturing process, and for a microchip there could be thousands of them. And so if you just look like the automobile, that probably has millions of discrete units of manufacturing processes versus like a food product or a basic product maybe that just has one material and would only have a few, like these iron bars or something. Just that would have a material. You might only have a few discrete units of the manufacturing process. But so an engineering industrial manufacturing process could be broken down into discrete units, every reduced point to which something is done. And it could be an addition of material, it could be a cutting away of material, it could be a bending, it could be a soldering, it could be countless possibilities. And it could also include just moving. So if it's just moving something from one position to the next. And so the automation process, so as mentioned, automobile. So automobile has thousands of parts in it, and the thousands of parts in the automobile all are manufactured and prepared to their final manufacturing point before they're put in the automobile. So if you broke them all down into their individual units, there would be millions of discrete units of manufacturing process in the automobile. But on the like final assembly plant or something like that, they might have hundreds of discrete units of lines on the engineering process. And many of those could be automated. So if you're talking about drilling, polishing, connecting, soldering, any of the manufacturing processes, could be additive manufacturing. Many of those could be automated. And also the moving along the piece, the product from one place on the manufacturing line to the next could be automated. Like the Michigan home Henry Ford and the Fordian manufacturing processes of the assembly line. And so even Ford back then, 100 years ago, had a conveyor belt that took the part station to station where it was worked on at each station. So, in the pre-computer digital age, but in the early industrial age, you could have a conveyor belt that would have taken the car engine or various pieces, and it would have taken it from one place on the assembly line where a worker, technician, engineer would have done something to it, and then it would have been after that taken to the next point on the assembly line. So now you could have robotics, and so like the industrial, just a conveyor belt. So in terms of a robotic industrial line, many manufacturing procedures have become completely automated, where people really only monitor it, and really the people monitor the computer's monitoring of the process. But that means that the piece is taken from one place to the next automatically from the computer, and then the computer, the automation, the mechanics takes the component and does the process to it, with a robotic arm, with an automated process. So that's really just a theory of automation, from the employment level, like Andrew Yang in my popular video on UBI of replacing people, and there's multiple understandings of the economic or social implications, which I'm going to leave out. I just want to talk about the engineering implications of the automation process. So you'll hear like a simple conveyor belt. If it was like a beverage, something like Gatorade or a power drink, or any facility where, in this company just says conveyor belt. So it said, this is basically a one-stop shop for everything you need for automation. So the conveyor belt just moves the piece along, and then you might have a robot that each stop along the process would do something. And if it was food, if it was chemical, producing the food, or if it's a part. So you have multiple purpose robots. So you have generic robotic arms, and they have specifications of how much they could hold, the degrees of freedom, type of movement, and the various type attachments. So you might have, one that has a paint attachment. That most robots are. I have a hard time with the messages, but yeah, thanks for tuning in. If anyone's watching, I have a hard time reading the messages, but I'll check them out later. So there's pneumatic and electrical. So if you're just looking at a robotic arm, it just has a rotational. Here you have different side, up or down. But most robotic arms are just rotational, and you would just have a signal that would either be pneumatic, that would be air controlled, or electric, that tells the machine what type of movement, exactly how far to go, and then the machine would do it. So you have what are called PLC, programmable logic circuits, which are kind of like computers, but they're really just electrical signals that are programmed. So as opposed to a computer program like the digital logic circuits, the machine code for a computer that performs, so to say, intellectual functions and commands, a programmable logic circuit largely just has stored electric impulse information. So if it's like controlling a robot, that you just want the robot to go to so if you have multiple axes of rotation, and you just have a signal going through the various axes that is telling it exactly how to move. So here, simple demonstration of robots doing various things, and their axis of freedom here, you can see it's rotating. It's got a I don't know, 4 or 5, maybe 6 axis of freedom, a rotational movement, and the electric signal would send it exactly how far to rotate and where to rotate to. So this would be, you'll say, a PLC, programmable logic circuit, that feeds directly into the machine and controls the electrical symbol. So the purpose of the programmable logical circuit is to feed an electric signal to power the machine, or if it's pneumatic, it would feed an electric signal to the air pressure tank that would put in the machine to move it an exact amount. And so you have various robots that have various levels of precision in terms of movement. So if you just have an arm that has multiple rotational axes, to what level of precision can the machine move? As I was mentioning yesterday, you have machines with up to microns of accuracy, millimeters of accuracy, and that will be the price point for machines that could be tens of thousands, hundreds of thousands, or millions of dollars. And most machines have interchangeable part heads. So this one's simple, just has a suction cup that you see it's not even going down, but that would pick up a part, and it could use a suction cup, it could use grippers, various methods, and a lot of those are interchangeable. And then you have the payload here. So not sure if this one's working. This one could just be scanning, or if it's balls, if it's a suction cup. And so I'm going to talk about also the artificial intelligence, machine learning, and vision scanners. But I wanted to first mention the programmable logic circuits, which are just a industrial box that feeds electric signals into the machine that control the machine. So the PLC circuit will feed the electric signals into the machine that tells the machine exactly what to do. And there's a specific language for PLC circuits that you could program, and it would be like a 3D printer where it's geometric, where you're giving geometric coordinates to the direction that the machine is going to move. There's also computer interfaces to do the coding in so most of these will have embedded cameras. So besides for the head, a lot of them will be controlled by some sort of machine intelligence that has an embedded camera or sensor that will help guide the machine. And that will involve some form of machine learning algorithm. So if you're talking about a piece that's picking up an object and moving it, that you could have the PLC circuit that has exactly pre-programmed movements. So, like this, if it's a sander, or it'd be a device or a piece that's performing some functions, that it could have the coordinates exactly pre-programmed in. If there's a discrete unit in the manufacturing process, and it's just repetitive, where the computer, the circuit is going to instruct the machine to do the exact same movement again and again. And so here, if you have a simple form of assembly, and this might be exactly pre-programmed, where the PLC circuit has pre-programmed the exact movement that it's going to go through, and it just carries it out step by step in the pre-programmed way, and it doesn't involve any form of machine learning intelligence. But For a lot of manufacturers, that's not sufficient, and the technology has increased, and you have machine learning algorithms for guided movements, where you have an embedded sensor, a camera. The camera would have some sort of recognition device where it would recognize the desired object, and then from the recognition of the desired object would feed back in and control the movement of the machine. So machine learning and artificial intelligence is a large process of the robotic process. So this, I don't know if they have a demonstration here of an embedded camera, but that would, so this is probably a simple repetitive process where it's going through the exact same moment of movements again and again, and it doesn't require any intelligence or direction. It's going to a geometric location that's the exact same, and then performing the exact same geometric operations in the exact same space. As opposed to if it had to meet a moving target or have some sort of direction, then it would have an embedded camera. The embedded camera would be connected to a computer software that would be able to recognize the device, and based on the programming, help direct the machine to the best course of movement to pick up that piece. And then, if it's like moving, some of these later demonstrations where there might be some intelligence of placement. So if it's like placing pallets, where you are stacking pallets very high, and you're not just going to stack one piece to the next piece like a conveyor belt. If you have a production line, assembly line, and the piece has been done in the process, and you're just taking the piece and then pushing it to the next point on the manufacturing process, a conveyor belt, where it's the exact same geometric space. But if it's like moving pallets, where it's not going to be put in the exact same location again and again, then there would need to be some sort of intelligence, and that could be programmed. So they have companies here that they have various robots. So like this company coming up here, Universal Robots. I'll head back there. Hopefully my reception remains good. But you could buy a robotic arm with the basic software for as little as $10,000. And what kind of payoff? Maybe just a few kilograms. So the various strength arms and the precision levels. And then they have simpler methods to some of the they'll have an interface software. So there's actual PLC circuit code that if you know the exact geometric programming language to feed it into the circuit and tell it what to do geometrically. That would be without any machine learning. So here I was mentioning like pallet moving. So it's not a simple procedure of kettle chips here. It's not a simple procedure of just repeating the same motion again and again, because it's taking off a pallet and each box is in a different location. So if the pallet is the same size every time, it could be completely pre-programmed. And so even if the pallet has like 100 boxes, the exact order it goes in could be pre-programmed. But they will also more likely use an embedded camera where the camera would see the location of the object, and it could also have some sort of computer intelligence that would be able to determine a stacking strategy. So, because it's not putting the same box in the same location, it's stacking the boxes so every box is moving to a unique location. So, simple. It might cost $1,000, the robotic arm, the software. If you can't program it yourself, you might need to pay a technician tens of thousands, maybe even tens of thousands of dollars to program the robotic arm. So once it's all set up and done, you would have a repetitive process that could operate even 24/7. Some of these have process per hour where they'll the software that make it very simple. Some of them are trainable, where you don't actually have to know the PLC circuit coding, and you could train it by moving it by hand. So if it's a simple, single, repetitive process that doesn't involve any intelligence, and you could do, as said, a lot of them would be a simple, repetitive process that you could get the robot, manually direct it how you want the movement to go, and then it would repeat. And there's some robots as little as $10,000. And then it said these companies here, some have over 1 million products of type heads, so like suction cups or grippers or the various things that what exactly you want it to do, that it would grip and or do whatever the process is. So you're here also in company demonstrating a computer interface and training. So Canova, simple teachable robots that also has a simple interface, trainable, that makes it relatively simple. And even for the machine learning algorithms, they also have simplified software where you could relatively easily drop and drag, show what you want the computer to do. So what's the object? You would train the object like machine learning on the object that you want the computer to recognize. So if they're picking up a certain object and the object is going to not always your desired object, and then also like a stacking sequence or a moving sequence where the computer's machine learning algorithm would be able to figure out for itself the best course of action in terms of movement, how the machine should go about moving to do the process at hand. So it said that there's machine learning software here that you could pick up somewhat cheap. You could, starting level of thousands of dollars even. The starting process of that's what goes on in my head, right? Pick up some more reading material. I picked up a lot of reading material, but so here's GoBot. Yesterday. So here are companies that have robotic arms. Here's an example of the PLC circuits. So this is just programmable circuit logic that has coded exact electrical signals for the process that wants to be replicated. So I say most industrial centers, it doesn't take their directions from the computer, it takes their direction from the PLC circuit, but you could feed in the computer to the PLC circuit, and so industrial controls is not the same, like computer, PC connected. It's more electrical, so you have circuits, you can have like chips, embedded chips, but at the end of the day, the machine is fed by electrical signals that are precisely controlled, that control how the machine moves over schematic, then that will control exactly how much air pressure is fed into the machine to cause the movement. So, I said this big convention be like a one-stop shop that should include everything. So, I said here is another box moving pallet exercise, and I don't know here if it would have exactly coded or if it has cameras. So one is taking the boxes, putting on the conveyor belt, and the other one's taking the boxes off. But it's not a precisely repetitive movement because it has to have some intelligence to stack the boxes. So it could be pre-coded where the computer knows the exact stacking pattern and on nodes and nodes in the exact pattern, or it can have embedded sensors and a programmable intelligence where the computer figures out on its own the best method to stack and unstack the boxes. And that would be a big price point difference. So if you got a cheaper one that didn't have the machine intelligence and the embedded sensors, it wouldn't be as easy for your manufacturing process because you'd have to have something that's exactly repetitive. And so here's the painting example. Paint applications are very common robotic use here, especially cars. Most cars are painted. Will be done with a robotic arm. But painting, if it has to follow an exactly repetitive process every time, it's going to have limitations and it's going to have increased programming. And most manufacturing processes are reconfigurable. So if you had, so here's machine vision solutions. So if you have major manufacturing facility, automotive companies, hundreds, basically unlimited budget, they're going to use the best technologies, to some extent spare no expense in order to get the process done, as opposed to if you're a mom and pop manufacturing process center and you have a strapped budget and you're looking to add your first robotic arm. So all these things are very expensive that you want to automate. Like I said, you could start your automation process for tens of thousands of dollars with just automating a single unit. For like tens of thousands of dollars, you could automate one process. And even to create a whole automation line, you could probably do it with hundreds of thousands of dollars versus if you're setting up a facility, like Ford building a new facility that costs hundreds of millions of dollars, billions of dollars, where they're going to use the top equipment from across the field. So here back is the Maxi Robotic Systems. Got some kindness people here. So you just see the demonstration of hopefully I don't lose reception, but we try to get in there of like a dance, a repetitive movement. And so you could just see 1 kilogram to 25 kilograms. The various robotic arms that have different payloads. And so if you just wanted to automate one step on your automation process, you'd have to pick out the right robot, then you need to train it, you'd need to code it. And so here might be a demonstration of multiple pieces on an automation line. So even something like this you might be able to set up for a few $100,000 versus if you just wanted to automate one process that might be able to do it for tens of thousands of dollars by just starting with a single robot. Versus if you want to design a whole facility like a final assembly plant for an automobile, and certain things that if you have people, you would have to have it planned what the whole process. It said that the discrete units of the manufacturing process, what part is going to be automated, what part is going to be manual, and like a physics equation, like a queuing system. So queuing theory is also very important. So the time that it takes on a manufacturing process for something to be done. So if one process takes 4 times as long as another process, you could either have a queue where you're going to have a backup, a backload, a bottleneck, or you could have 4 machines. So the process that takes 4 times as long, you can have 4 machines that are doing it in order to make the process even time. So here's demonstration of embedded scanners where there would be some sort of intelligence to pick up the piece and guide the piece. And so you could see the scanning equipment. So here you see the screen up there where it has the recognition device, where the computer has recognized the devices, it's mapped it out, and then it creates a plan of attack. So simple, if it's numbered, so there was a failure there. So there's a piece failure, and then it corrected its mistake. So it picks the piece, gets it, drops it in the other. And there you see the 3D vision sensor up top that is scanning the image creation, the recognition of what wants to be done, and the carrying out. So a lot of good demonstrations. Unac, one of the bigger robotic manufacturers. This is a painting procedure where it'd be spraying something on it, different objects, and it might be scanned. So it goes under a scanning, and then after the scanning, it coats it with something a little interesting. So I'm a little unclear what's going on. But it would be a scanning, and then a machine learning program might try to decipher the best course of action for moving the product. And so you're saying for heavy manufacturing, it would be designed with embedded sensors and guided in programs. But sometimes it's not necessary, and it would be an exact repetitive process. Could be medical devices or drugs, machine. So this, I guess, would be an example of pills. I don't know, it'd be like pharmaceutical or something, putting in but in certain direction. And so you could see the cameras. So it does have camera sensors, machine. So you could have a machine designed exactly for your needs. So if you were a pharmaceutical company or something, and you wanted a process designed exactly for your need, it might be too complicated to buy a robot and code it yourself. So you could work with the companies that would configure it for you also. And they also have consulting companies. Like Google's a consulting, cost estimating. But you have established robotics consulting companies that would be able to precisely tell you your options, how much they cost, and then carry it out for you. Say that if you have a certain manufacturing process and you want to automate it, and tell you how much it's going to cost, what are your various options, and the price points, and then contract it out, buy the equipment, set it out, do the coding, and maintain, like a computer contractor will maintain the contract over time. I apologize in the chat. I appreciate the messages. I'll have to read them later because I'm on my cell phone, so I can just see that the messages are, chat is being written, although I can't see it long enough to interact. So let me ramble on a few more minutes. I might try to pick up a little bit more reading material, and then I'm going to get out of here. But I'm glad I came back today and get a better feel for, it's an international conference, a lot of great equipment and interesting stuff here, experts in the field. If you even try doing like interviews or something, that I'm probably not going to do. I mean, most people here are probably professionals and pretty friendly, and you could walk up and they probably even on camera explain. They have actual press passes of official press that are here. A lot of these companies have their own YouTube pages, but I don't think I'm going to do any interviews today. Maybe in the future, something else I'll look into. So, pretty cool. You see, it's a huge floor. I'm still seeing things I hadn't seen yet. Walking around and new demonstrations of different equipment, and walking around still seeing new stuff. So a lot of these companies would be able to design a full assembly plant if you're a major manufacturer that was ready to spend $100 million and get the top of the line equipment in order to make hundreds of thousands of parts, or even to automobiles, to a mom and pop shop that just wants to automate one single process and has a shoestring budget that you want to spend as little money as possible. There's also robots you could get for your house. Like the vacuum, Sharky vacuum. Various automation, machine intelligence, security systems, door locking, military equipment, anything, just the pure physics. Because Detroit is mostly centered around automotive, and the reason the conference is here is because Detroit is still probably the single largest automotive center, even though it's been depleted and continues to be depleted. But so most of these are focusing on industrial and automotive, but it's an automotive like a final assembly plant versus the thousands of parts that go into final assembly. So automotive manufacturer, where you could be a mom and pop manufacturer who just does one single product, or you could be a major supplier that basically, like Bosch or something, that supplies basically every single component that goes into automobiles. And the various fields, people selling materials or lubrications or various things that all these people would come. This is economics. So if you're a member of the organization, it costs thousands, tens of thousands of dollars a year. You get your name in big, or have more part in the actual process of the conventions, or you could rent a booth. I'm not sure if single entry booth, it might even be as little as like $1,500 or something like that. Hundreds of dollars. Some of these conventions, it's only thousands of dollars, hundreds of dollars for a table. So you could be a mom and pop shop that decides to invest $1,000 into a show. And a lot of these international companies, the company comes where they will have multiple people. So they'll have some of their trainers that they'll come and go to the conference and attend the educational sessions, be trained on some of the newest equipment. And then they'll have their sales force where the people manning the table, they might have some of the technicians, engineers, scientists to answer questions, but basically sales or informative company promotion, networking, and this is just the convention part. There's also the conference, which is educational. So a major company might bring like 100 people here, or tens of people, or you just be like 5 people. So that's the way all these conventions work. And a lot of cool stuff here. So also more 3D printing.